in today's class, we are going to learn physics, okay? Okay. So physics first, okay. Which standard are you going? You are going to 11th standard, right?
Yes, ma'am.
Okay. What's your ambition in life? Oh, I can't hear you properly.
Automobile engineer.
Automobile engineering, right? So for getting a good college, you have to take JEE Mains exam, right? You know that or not? Yes. So you have to concentrate on physics, maths, and chemistry, right? Yes. Okay. So today we'll be going to see some physics basic concepts and units and measurements. Okay. And we'll be solving JEE Mains problems also. Okay. In the later classes, we'll be solving that. Because it's a basic class, we are going to see the units and measurements. Okay. I'll share the screen with you. Okay. What is a physical quantity actually? Any ideas? There is a quality and the quantity, right? There is a difference. So what is the quantity?
Quantity is amount of.
Okay. So quality means how do you measure artistic? Okay. Here they have taken a thing. Okay. Two things they have taken. Quantity measurement. What can we measure with the instruments on an aeroplane? Okay. So two examples they have taken. Okay. So most observation in physics are quantitative. Okay. It's not depends on the quality. Okay. Or most of the observations we use quantity, right? Okay. So the basic observation is quantitative only. After this only we go with quality. Okay. You understand? Now okay. So here you know the difference, right? Now you know the difference. So two examples we have given and you know the difference now. Magnitude and unit. So what is a magnitude? What is a magnitude and what is a unit? So magnitude means just a number. Okay. And unit means it is a common thing for measuring. Okay. So length if you're taking means you have to measure it only with meters, right? Meters, kilometers, it varies, but the common unit is meters, right? So magnitude means how much amount, okay? Number or the amount I can say, okay? For example, here they've taken a measuring length. So 70 kilometer per hour. So kilometer per hour is a unit. That won't change. So if you are measuring a speed, that won't change. But the magnitude keeps on changing, right? So unit is a common thing. It's like a naming. Okay. Yes. So now SI units are common today. Okay. Why we are going with SI units? Any ideas for going with SI units?
Because it is standard and
It is standard, but that okay. It is standard you have said, but that are made by an scientist, right? Why they have made this as a standard unit and not any other units? CGS system was there, SI unit. So why they have taken this? Why we are going with SI units?
Because this is accepted worldwide.
Accepted by the world. Okay. Other than that,
These units are commonly used everywhere.
okay, dear. The basic thing is it's commonly used. You are saying, okay, okay. So for people in different world, they use different languages, right? So the same way, the measurement also varies according to the. So in the earlier times, we were using stones, right? The kgs and all in stones, and not every people do that. Even in rupees, what we do, we use Indian money. And what about other peoples? Like US people use dollars, right? So it's not common. So if it is different for all other, it's varying for the measurement is varying for all other countries, means what happens? There is a confusion will occur, right? Chaos will occur, right? So the thing here is to avoid those confusions, because we are also dealing with the foreign scientists, and right, not only our Indian scientists, we are dealing with foreign scientists. So to avoid those confusions, we have taken a standard system of units. Okay, first thing. And second, this thing is it is very easiest to measure. Okay, so 1 pound, pounds and all, you know, right? So pound measurements, that and all, you know, miles. So if I take miles, those things and all, it will take 1 mile is equal to 1.07 kilometer. So every time I have to substitute that, right? So no need for that. So only they have made a standard unit. Okay. So for easiest thing they have done that. Okay. Any doubts in this? Any doubts means you can pass and ask. Not only in this class, in any class you can ask. Okay. Yes.
Can I
So
note it down?
yes, Pawan.
Can I note it down?
Yes, you can note it down. This point alone you can note it down. And what is a magnitude means just a number and an amount. Okay. So in physics we will come across with a lot of new terms. Okay. So magnitude means you have to know it's just a number or an amount. Unit means it's a common thing. Okay. So these are all examples. Okay. Okay. Physical quantities, they are classified into two types. Okay. Base quantities and derived quantities. Okay. So base quantities, only 7 quantities we have that I'll provide you. Okay. And derived quantities means those quantities are came from the base quantities. Okay. One simple example for understanding this I'll give you. Okay. Okay. For example, distance. Okay. Distance, how you measure distance? The unit is what? Meters, right? Kilometers, millimeters, everything is okay. That and all the variation, then magnitude. Okay. But meter is a common measurement, right? Okay. What about time? Measuring a day. Seconds.
Hours also.
Seconds is the very basic unit. Okay. Without seconds, you can't even count the hour, right?
Yes,
Okay. Yes. So here these two are other than this, any other basic thing for this? No. These two are very basic units. Okay. So here I have taken a distance and time in seconds. Okay. So if we are taking a day and you have to measure 1 day, 2 day means you have to take time, right? So in a second you can convert a day into a seconds, right? So per hour you can convert into a 60 into 60 minutes you can do, and you will getting 300 600 seconds, right? Yes. So this and all my basic or fundamental quantities they used to say. Okay, fundamental means base. Okay, so fundamental quantities. Now the thing here is, what about my derived quantities?
it said bought through formulas.
Okay, derived quantities, I'll tell you. is equal to, speed is measured using what?
Meter per second or kilometer.
Yes, distance per, total distance traveled divided by time taken. So that is what we call it as a speed, right? So here my measurement is what? Actually my measurement is meter divided by seconds. So these two are my basic quantities and this is my what? Now the speed is the derived quantity. It is derived from the base. It is depending on the base quantity, right? Just take it down this.
Yes. Yes.
Okay. Again, you know the term velocity. You come across velocity? Okay. So velocity means displacement divided by time taken. So there is a huge difference between speed and velocity. Okay. Which makes the difference is distance and displacement. Right? So that difference is and all I'll tell you clearly. Okay. This is only for your basic understanding. This derived quantity I'm giving. Okay. That and all we'll see. No need to worry about it. Okay. We'll provide you the class for that also. Okay. So this displacement divided by time taken is also my meter per seconds. So it is also a what? Derived quantity. Right? So it is also a derived quantity. Now you understand. So what are those things? Okay. So just take it down the velocity formula also that we'll discuss later in the class.
Yes.
Okay. So here they have given a simple example. So base quantity is like a brick, the building block of a house, right? So without the base quantity, you can't build the derived quantity. So that is what the thing is. Now you understand. Now it's clear, right? Yes. So SI units, International System of Units. Okay, these are the base quantities. Okay, you can just take it down the base quantities. 7 basic quantities. Okay, length, meter, the symbol of the unit is m. Okay, so I already told it is the naming of the unit, right? So it is a meter and it's m, and mass, kilogram, kg. Time means it's always second and the unit you have to represent using small s. Okay, you should not use capital S. And the electric current is ampere. Okay, temperature is Kelvin. Okay, amount of substance is mole. Luminous intensity is candela, CD. Okay.
Yes.
Okay, just take it down. These 7 SI units. Okay.
Yes.
You have written this?
I'm in the last two.
Okay.
Yes.
Okay. So for SI units, this platinum, okay. So the basic, how they have measured using, which is a meter and the kilogram, everything, right? So this platinum iridium cylinder is the standard kilogram. Before that, but 2019, they have changed it. Okay. So the debates are still going in between the scientists, like every unit we have to change everything. The conflicts are still going. Okay. So still in your books and all, we deal with this only. The platinum iridium cylinder. Okay. This is a standard kilogram. So this and all you have already learned in the lower classes, right?
A standard kilogram is, I couldn't understand. That is perfect kilogram or
What, Pavan?
what is standard kilogram? What is difference between just kilogram and standard kilogram?
No. Actually, the basic thing, which nothing but a standard kilogram is nothing but the kilogram unit they have taken. No, for that they have to measure from a small quantity. For example, okay, Earth is rotating around the sun, right? This example I'll tell you, then you can come to know this. Okay, the basic unit time we have taken. Okay, so measurement time we have taken. So for measuring a day, we have to use time, right? You know that. Okay. What about the leap years? Why we are measuring 4 years once? We are measuring 4 years we have taken, and the 4 years once we are taking a leap year. Why we are doing that? Every year then should be the Earth is rotating around the sun. Okay, cool. But why we are taking the leap year? Any ideas? No. Okay. I'll tell you, actually, the 1 year is 365 1 by 4. Okay. Actually, the 1 year is this only. Okay. The measurement. If we count using the seconds, for 1 year, we are getting 365 and the quarter days. Okay. But we cannot do that, right? We want to celebrate New Year, everything, right? So
Yes.
the people made what means that quarter into the whole one. So only 4 years one we are celebrating the leap year. You understand? So only in the February we'll be getting 29th on the leap year. You understand? So the same way. So the measurement we have changed accordingly, right? Why? Because means for 24 hours, 60 seconds we have taken. If we take 61 means what happens? Then the whole thing will get changed. Approximately, we have to make it clear, right? So you understand? The same way, we have to take a basic thing. That is what my iridium cylinder here. On the previous slide, we have seen, no? The platinum iridium cylinder is a standard kilogram means based on this cylinder only, we have measured the kgs. Okay, that is what they are saying, the standard kilograms. Okay, you understand now? Yes. So the same way. And area, volume, everything is measurement or not? Everything is a measurement, right? So it is 2D. Okay, I'll tell you one thing here. It is a 2D measurement. And what about volume?
It's a 3D.
It is a 3D, right? So only we'll be getting meter cube. So it is a derived quantity or a basic quantity?
It's derived.
Derived quantity. So area is meter square, right?
That's also derived.
square meter, units we used to write. So everything is a derived quantity. The basic unit is meter only, right? Yes. So here, why? Because means volume means length into base, right? So everything is meter. Height also we measure using meter. Everything. So it would be easy for us to, if I give her height 1 unit, base 1 unit, everything, if I give different units, means what will happen? Confusions occur, right? And we don't make our studies easier, right? So only the scientists have made it into an SI units. Okay. And force. Force, basically the unit is Newton, right?
Yes.
In smaller classes you have studied, but what is the formula for force actually?
Meter per second square.
No, dear. Force is mass into acceleration,
Yes.
right?
Yes.
Yes. So it is mass into acceleration. So force, if you are providing means some sort of acceleration is needed, and your hand is your mass, right?
Yes.
So greater the mass. So both are directly proportional. Directly means both are in numerators, right? Which means when the mass increases, force definitely increases, right? If I'm hitting you with a rod means it depends on the mass, and if I hitting you with a small stick means your hurting is according to the mass, right? So if the mass increases, then the force will accordingly play the role. And also acceleration increases, then force is also increasing. So force is dependent on both the things. Okay, so directly proportional. Okay, so mass into acceleration I have taken. So what is the formula for acceleration?
Force divided by
Okay, being a smart, okay, being reacting like a smart. Okay, so acceleration is velocity by time taken. Okay, I'll tell you everything: speed, velocity, acceleration. Three basic units are like it is depends on the previous units. I'll tell you that and I'll provide you separately. Okay, no need to get confused. Just take it down now. What is acceleration? Velocity divided by time taken. Okay.
yes.
Okay. So now here they are given an acceleration, right? Force, acceleration. Okay. Pressure, work, pressure, power. Okay, what about pressure? This is under basic units you have studied in the lower classes itself. Could you tell me the formula for pressure?
Pressure is
Force by area,
force by area.
right?
Yes.
Okay. So here pressure is equal to F by A I can take, which means Newton per meter, right? Okay. So now force is my mass into acceleration. That's okay, cool. Okay. So now when the area decreases, pressure increases or not?
Yes, ma'am.
Yes, because both are inversely proportional, right? So pressure basically depends on the area. For this, a simple example I'll tell you to keep in mind what is the pressure, and this formula you should not forget. Why? Because means it plays a major role in mechanical properties of solids and fluids that you will study later. Okay, the upcoming classes you study that also. So keep in mind. For example, okay, straw. You love to drink juices, right? Juice or any soft drinks, right? So you used to drink. We have used it using a straw. We have sucked the juice, right? So what if the straw's area is very very big?
Um, we
You
need
need
to
lot of force to suck, right or wrong? Think of it, if it is a very big like our mouth, it's very big means we have to suck. What to do? We have to suck. We need lot of force, right?
Yes.
Yes. So very small area means not that much force is needed, right? You understand?
Yes.
So if this is very less means, then the pressure, for pressure means we are giving a pressure and we are sucking it, right? So a lot of pressure is not needed, automatically it comes. Okay. Think of it, I'm taking this pen. Okay. So this side is having a very big area, right? And the tip side is having a very small area, right or wrong?
Yes.
Very small area. Okay. If I hit you with this back side means there will be some sort of pressure or not? Okay.
Yes.
If I hit you with the front side means there will be pressure or not? In which side the pressure is more?
I mean the tip side.
Tip side. Why? The
Because the
area is
area.
very small, right? So
Yes.
pressure depends on the area. Okay, even in the syringes, if we take means why the lid is the fluid container part is very big, but the lid is very small, right? Why? Because means it's a basic thing. So everything is physics, right? Okay.
Yes.
So work done, you know, right?
Yes.
It is a force into displacement, right? Just take it down the basic formulas. Okay, everything you'll study in your classes. Okay, so force into displacement.
Yes.
So units of area, volume, length, width, height, and density is mass by volume, right? This formula you just take it down. So mass by volume, and unit of density is mass is what actually we represent using kilograms and volumes in meter cube, right? So just take it down this. Yes. Okay. I'll tell you speed, acceleration, force they've given, but the order to write this is speed first you can write. Okay. So speed first write. After this, I'll give you second one is velocity you have to take.
Yes.
So don't forget this order. Why? Because I'm telling you means I'll tell you velocity is equal to displacement divided by time. Okay. And third thing, after this only acceleration comes to play a part. Okay. So this here acceleration is equal to again the velocity. Okay. Velocity divided by time, which means the velocity when it is varying, I'll give you the time to write. Okay, you just first listen. Okay, after that I'll give you the time. Okay, first speed. Okay, it is distance by time, you know. Okay, it is also meter per second and it is also meter. Then what is the difference between those two? Means one difference is there, that is my displacement. I'll tell you the difference between distance and displacement, that also you can take it down. And acceleration is when the velocity varies with time, we get what? Acceleration. Okay, what about getting acceleration varies with time?
Acceleration divided by time.
Yes, what is my acceleration divided by time? Actually, we won't use this equation, but it's like a fun fact. Okay, acceleration divided by, you're accelerating Okay, think of a bike. Okay, you're riding a bike and you're accelerating per second, what you will get? Accelerating and stopping, accelerating, jerk, right?
Yes, yes, ma'am.
You will be getting a jerk. In American English, jerk means idiot. So people used to say, I'll tell you that equation. You know differentiation. What is mean by differentiation? D of f of x divided by dx. That you will study in maths. Okay, not a complicated thing, easy thing only. Okay, that you will study in maths, which means I am differentiating with this function with respect to this. Okay, for example, if I'm taking a speed means, okay, I'm the speed is varying with according to what? Time. Okay, so the same way here, what I can do is this velocity is varying with time, which means I can write this as dv by dt. When the velocity, this function is varying, which means a small amount, I'm differentiation means getting a small amount. Okay, so d by dx, which means getting a small amount. Okay, from a larger amount I'm getting a small amount. So velocity is a whole thing. Okay, from that whole thing I'm going to get a small amount. What is that? I call it as differentiation. Okay, which means getting a small amount with respect to what? Differentiation I'm doing here with respect to the denominator. Okay, so keep in mind denominator we used to take. Okay, so the function is a numerator and the thing we are taking is a denominator, so which means dv by dt. Okay, then I differentiate this with respect to what? Acceleration means dA by dt we get what? Jerk. So this is the order. One thing I wanted to tell you now, let's take x as a speed. Okay, let's take x as a speed. Okay, when you differentiate this with respect to time, you get velocity. I'm so sorry, we are taking this as a distance or a displacement. Okay,
Yes,
yes, so this is a displacement I'm taking. So when you differentiate this, what you'll be getting?
velocity.
When you differentiate this velocity, you will be getting velocity, right?
Yes,
Okay. Again, when you differentiate this double time, which means you are differentiating this, right? When you differentiate the velocity, what will you will be getting?
acceleration.
Acceleration, right? And when you differentiate this acceleration, d cube of x divided by dt cube, you get what?
Jet.
So it's a quad they used to say, don't be a dt cube x divided by d cube of x divided by dt cube, which means don't be an idiot. Okay,
Yes,
so if you want to scold some person means you can use this. Don't be a d cube of x divided by dt cube. Okay, so this we want to use in classes, but this 3 is very much important. Okay, you have to take a displacement when you differentiate this. So now you understand the order.
yes,
Speed is like a, okay, distance and the displacement difference I'll tell you now. You just take all those things down. Okay, so in the side by side you can write like this itself. Okay,
yes.
yes.
Yes,
Okay, written everything, these equations. You apply in JEE mains exams. This kind of equations only they used to ask. This kind of simple
Right.
questions.
The
This green
green
color
color
also. Yes, that just take it down. Okay.
yes,
First write X and the 1, 2, 3, 4 order itself. You can take it down. Okay.
yes, yes.
Okay. This we have written already. Okay. So pressure is equal to force by area. You have already noted down, right? So work is equal to, and power, work done by time. So how much work done according to the time, we call it as a power. So these are all basic units, right? This time is my basic unit, and this work done again it's force into displacement. Again, force is MA. So these kind of quantities are my basic units. Okay. You know how to convert these things into a basic unit. Then only you can do with dimensions. Okay. We'll ask questions with dimensions that I'll tell you. Okay. So dimensions, just note this. This would be easy for you. Dimensions means only 3 basic dimensions. Okay. So first thing is mass, which represent using m. Okay. So second thing is length, which we represent using time. Sorry, L. Okay. And the third thing is time, and we represent using T, capital T. Not seconds, it's the dimensions. Okay. Just take it down this. Now let's do a dimension for this. Okay. For power, what is the dimension? If they are asking means we can use this. Okay. Just take it down this.
Another doubt.
What power?
Another doubt, ma'am. For work
Yes, yes,
written force into displacement, ma'am.
yes,
That this work and work done both are same.
yes.
Next
Both
equation.
are same. Work done and work done is equal to force into displacement. Both are same. Okay. No issues.
Yes,
How much amount of work is done? Okay. So
yes,
if you have doubt means you can just take it down here, work done. Okay. Yes.
yes, ma'am.
Okay. So what is my units of pressure? Unit of force is what?
Newton by area.
Meter square. Area means meter square only, no? So
Yes,
Newton per meter square. Okay. And force into displacement, Newton into displacement is what? Meter. Okay. What about force into displacement divided by time? It is Newton meter per second. You understand? This, just take it down.
yes,
Okay. So the dimensional unit they'll ask in the questions. Okay. What is the dimensional unit? Then what you have to do is, in terms of dimensional units, just you have to take the unit. Okay. So what you have to do here means, you can take force means what? Mass into acceleration, right? So you can first write mass. Mass means represented using what?
M.
M. So M. Acceleration is actually what? Acceleration is velocity by time, right? So which means meter per second square. Okay. Velocity is equal, velocity we represent using displacement. Okay. Now let's take acceleration is equal to velocity by time. Actually my velocity is what?
Meter per second.
Meter per second divided by second. So if I arrange this, I'll be getting what? Meter per second square, right? So mass into meter per second square. So instead of mass, I can write what? Meter per second. So meter is what actually? Length.
Length.
So I can use L divided by S the whole square. Okay. And again I'll be having what? 1 divided by S, which means seconds. Second means what? Time. So here time is represented using what? T. So this, I'm so sorry, I've written here S here. Okay. Sorry for the confusion. Okay. Here T, right? So dimensional unit is time. Time square. So what happens here? This square and this T get cancelled. So I can write M L T inverse. So this is my dimensional unit. Okay. In dimensions, dimensional formula or dimensional unit I can see.
This MLT the whole power minus 1 is for acceleration. I don't know. Or
What, Pavan?
this formula is only for acceleration alone.
This formula is actually, I'll tell you, I think you have got a confusion. I'll tell you, okay? Dimensional formula, we have to write same as the units. So if you are taking time means you have to put seconds only, right? So for each and every unit it varies, okay? So that is what the thing here is. We can take, so power only we have taken, right? So how the 7 units you have taken, and instead of the derived units, you can put the units, right? The basic units. In the same way, if we are providing with the dimensional formula, you have to take these 3 units, okay? So just take it down, dimensional formula that you have already noted down, right? I think you have noted down. So mass means it is represented using M, which units in kilograms, right? And for length, it is in meters, but we represent using L. And for time, it is seconds. Okay, so these are the dimensional formulas. Okay, what is the dimensional formula for power we are going to calculate? Okay, power. Okay, actually, what is my power formula? Work done.
Work done by time.
Yes. So work done by time. So this is not a basic quantity. Why? Because means if I know the basic quantity only, then I'll know the dimensional formula, right? So the same way, work done is equal to what? Force into displacement divided by time. Actually, what is my force? Mass into acceleration into displacement divided by time, right? So again, my acceleration is what? Velocity divided by
Time taken.
Time taken. So here, for mass, I can use dimensional formula, right? Which is M. For acceleration, it is meter per second square, which means what is my dimensional formula?
L by T square.
L by T square. right? And what about my displacement? It is in meters, like L, right? Again,
Yes.
my displacement is also in L, right? Into 1 divided by T, I can write like this or not, 1 divided by T, which means time, right? 1 divided by, again, what is my time,
Time is T.
right?
Yes.
So if I write like this, I'll be getting mass into L the whole square into divided by
T cube.
T the whole square, right? You understand?
Cube.
So now when we take this to the upside, what happens? T cube, right?
T
Yes,
cube.
T square into T cube. So when we take this to the upside, ml square T the whole inverse cube. So this is my dimensional formula. Now you understand? So this way you can write it for force. Now next we'll do it for force.
Yes.
One more example so that you can
Can I
understand
note
better,
it
right?
down?
Yes, yes, you can note it down.
Yes.
Okay. So now let's take for pressure. Pressure, you have to find the dimensional formula and tell me the answer. Okay.
Yes.
Yes. What is the dimensional formula for pressure?
An area comes under mass.
Area, you have to use meter square only, no? Right? It is square units, which means yeah, length, right? So L the whole square, right?
Yes.
L the whole square. Yes.
M L minus 1 T minus
What, Pawan? L?
1. M T minus 2 L minus
Okay, you have to write in this order, MLT order only. Okay,
1. Then M L minus 1 T minus
ML minus
1
mm,
and T minus 2.
and T. You have got
T minus 2.
T minus 2. Okay, let's check this. So you'll be having M, and instead of this, very good. Very good, Pawan. So you understand, right? Yes. Okay. Here are some questions. Area, volume, density, speed. We know that, right? The units and all, we have already did this. And the special name, we know that, right? The square units. And volume, we have taken a length into meter cube, right? Density is mass by volume. So that and all, we have already done, right? So we'll go with the next one. Okay. So the prefixes. Prefixes means very large or very small quantities. Okay, so they are also a quantity. Millimeter, centimeter. So in scales and all, you know that cm they have written, which means centimeters. So just write like this, okay? So 10 power minus 1 means it is represent using dm, which means decimeter. Okay, so cm means centi. Centi means instead of the centimeter cube, instead of the centi, if you want to convert this into meter means you can simply put 10 power minus 2 into meter. Now it's converted into meter or not? Okay, conversion of centimeter into meter. So the same way, instead of milli, you can use what? 10 power minus 3.
3.
Micro, you can use what? 10 power minus 6. Nano, you can use what? 10 power minus 9. So, okay, what about the positive terms? 10 power 3, which means a big number, right? 1000. So, kilo. So, 1 kilogram is equal to how much grams?
1000.
Yes, instead of kilo, you can put what? 1 into 10 power 3, which means 1000 grams. So, 1 kilo is equal to 1000 grams. You know the difference now? Yes. Just take it down the power, abbreviation, and the prefixes. Okay? Yes.
Yes.
Okay. Okay. So alternative writing method using standard form. So n into 10 to the power n, where 1 to 10 in the power lies where n is an integer, which means any numbers. Okay. This n is an integer means what? Minus 1, 0, plus 1. So these kind of numbers which going on infinite. We take negative numbers also, we call it as an integer, right? So any numbers we can write like this, and the 1 this n. Okay, this n is represented in between 1 to 10. In 1 to 10, it between any value. Okay, in between any value, this n is an integer. Okay, now this galaxy is about 2.5 into 10 to the power 6 light years from the Earth. Okay, so this must be any value. That is what they are saying, which is an integer. So it might be negative or it might be positive. Okay, no confusions, right? So, and the diameter of this atom. So, galaxy is very big, right? So, this is a big example. The galaxy is very big. So, it is 10 to the power 6, right? Which means mega, right or wrong? Kilo, mega, right? Yes. So, diameter of this atom means very, very small, right? Which means 10 to the power minus 10. Okay. You understand the difference? So for very small, we have taken this example. Okay, just an example. Okay, to understand a way better. Okay. Okay, these are the things we have learned in the class, right? So physical quantity is a quantity that can be measured and consists of numerical magnitude and a unit. Numbers and a unit. Base and derived quantities we know. 7 basic quantities. What are those? Just read this loud.
Length, mass, time, temperature, amount of substance, luminous intensity.
Okay. So SI units for length, mass and time are meter, kilogram, second respectively. Why? Because they have separately taken this, means from this only we have the dimensional formula, right? So M and time we can take T. Okay. Okay. Prefixes are used to denote very big or very small numbers. Okay. So prefixes also we have learned, right? Okay. So these 4 questions, just take it down. These 4 questions. Okay. Just you can note this down and you have to solve this and send it to in a mail. Okay. In physics mail you can send. Okay.
Can I take a photo of this?
Okay. If you okay, that thing is you have to take the question and you have to send it in mail. Okay, after solving it. Okay, you can just take 2 to 3 days of time and after that you can send. You know the mail and all you have got or not?
Yes, ma'am. I got the mail.
Yes. Okay. The physics portions you have to send in the physics mail. Okay.
Yes.
Okay. So this alone we'll see. Okay. Getting bored of class?
No, no.
No. We'll continue.
Yes.
Okay. So scalar and vector quantity. Okay, this and all you have already studied in the lower classes, but the meaning, whether you have studied in brief or not, that I don't know. So we'll discuss it here. Okay. So what is a scalar quantity and what is a vector quantity?
And scalar quantity only shows the magnitude. Vector shows
Okay,
magnitude with the direction of
with the direction. Okay. So it is very, very important to know about, and vectors we represent using I vector, k vectors in physics. Okay. So these are like x, y, z and all variables in maths we do, right? So same way, we usually take I, J, K as a vector, which means that object is, suppose if I'm writing xi vector, so this addition vectors I'll be writing, okay, yj vector plus zk vector. If I'm writing like this means x, y, z, three parts are having some sort of directions, okay, okay. So this and all we'll study in the Cartesian coordinate systems, okay. In kinematics you will study this, that I'll tell you, okay. Now no need to get confused, okay. Scalar quantities that have only magnitude, okay, and vector quantities having both what? Magnitude and direction. Okay. So for this simple example, I'll tell you. Okay, here they have given example for measuring the mass. Only it's what? A weight, right? Okay. Now tell me what's the difference between weight and mass?
Weight.
Actually, in yes, Pawan.
Weight is force exerted by that mass.
Force
Exerted by that mass.
Okay. Mass is?
Mass is the size of an object.
Mass is size of the object. Then when you go and buy something, the people used to tell what is the weight in kilograms. Why they are telling like that? What is the difference?
The force exerted by the mass is like, so they calculate.
Okay, I'll tell you. Actually, mass is the correct term. So only in physics, everything we say, what is the weight of the orange? You don't use to say that. Mass of the object, right? Actually, the correct term is also mass, right? So mass only kilograms. But weight is actually the formula for weight is what? Weight is also having a formula m into g. Okay. So weight means mass into gravitation due to acceleration due to gravity. Okay. So weight varies in space, but mass is not varying. Mass is a constant. Okay. So this is a constant. Okay. Your somewhat a gravitational force is exerting on us, like you have said, right? So the same way in mass in space and all, our mass varies. So only we are floating like an object, right? So there is no gravity. So that we don't call it as a weight. Weight varies accordingly, but mass is a constant. Okay, that is what the thing. You keep in mind this also you'll study in Archimedes principle. So everything you take, you come across everything. So just simple things you have to keep in mind. Okay, you have to put in those things, those stuffs in your mind. Okay, so mass is a constant thing and weight is a varying thing. Why? Because means it depends on. Actually, acceleration due to gravity is also a constant only, right? 9.8 meter per second square. But why it's varying means it's according to the gravity present in that area. Okay, in space there is no gravity, then it is zero, right? So the weight. So only there is no weight means the objects will float, right? So only weight is zero, but mass is somewhat present. We have a mass, right? You understand the difference? Okay. Here we are measuring mass. Okay. What about measuring a temperature? So the fluid moves in particular direction, right? Okay. So in simple example, so this is a vector quantity, right?
Yes.
The fluid inside it having a vector quantity, the movement. Okay. So that kind of example. In this also, it is moving. It is only, it's a constant scalar. But this object is moving, so it is a vector quantity, the measuring object. You understand? So for rockets and all, we are launching. Okay. The space station is having somewhat a cubic structure. If I take means that is only having a volume, right? So that is only my scalar quantity. It is having no direction, right? But the rocket which I am launching is having a direction, right? Which is my velocity. I don't say it is a speed. Okay. Now here comes the point, distance and displacement. Okay. Now I'll tell you this distance. Speed we have studied, no?
Yes.
The speed we have studied, that is a distance. And vector we have studied, no?
Yes.
That is a displacement. Okay, now you understand, which means velocity is having
A direction.
a direction. Okay, but speed is not having any direction. Okay. Okay. So the major difference is this distance and displacement. I'll tell you. You are here in your home. Okay. And you people go to schools, right? Okay. I'll take a school as an example. And you are going to a school. Okay. From here to here, you are. Okay. What is that distance means? You are going from this home to school, H to ES, and you are coming back. Okay. Okay. So the total distance I'll take 5 kilometer. You are going by walk. Okay. Bicycle I'll take. So 5 kilometer. And here also 5 kilometer I have taken. Okay. So my distance is, the total distance is what? Actually, what is my speed? I want to calculate the speed and the velocity. Okay. Now, what is my total distance?
10 kilometers.
10 kilometer, right? Okay, divided by somewhat a time. That gives my speed. What about my velocity? What is my displacement?
And the same 10 kilometers by time.
No. Here, what
Because
the difference comes?
the straight line.
What?
It is in straight line, so it is the shortest
Shortest distance. That definition is why actually in physics the definition has to be applied in somewhat a particular place only we have to apply. The definition application also I'll tell you. Okay. That I know you people have studied this shortest path covers, which we call it as a displacement. Okay. But the displacement means here displacement can be both positive, negative, and zero. Okay. But the distance,
is only positive.
somewhat a network fluctuations are there. Now, can you hear me?
Yes, I can hear you.
Okay. So the distance is always positive. Distance is just a measurement. Okay. So only measurement. Measurements when you take when you say about your weight, I'm minus 48 kilogram. Like that you say no. It is only a positive thing. It is only a magnitude. So it is what a positive thing only. It's just a number. Okay. So you start measuring from zeros, right? Okay. So the same way here in displacement, which could be negative, which means it depends on the direction, right?
Yes.
So here my displacement is plus 5 kilometer for going towards yes, and coming back it is minus 5 kilometer. So total displacement is what?
0 kilometers.
So my velocity is 0 here. Okay. So the displacement is, you understand?
Yes.
Okay. What about you have stopped here? Somewhat a canteen is there here, and you are hanging out with your friends. You used to hang out with your friends. Okay. Then it is 2 kilometers. Now here, what is your displacement? From this point to this total distance traveled. You're going to school, and after coming back, you're taking this. Now, what is your displacement? You have gone, you went to school, and you are coming back, okay, to the canteen. You're not reached a home, but you are coming back to the canteen and you are staying. What is the displacement that you have went to school and for coming back to a canteen? The total displacement. So it is plus 5 kilometer minus 2 kilometers. So the displacement is what?
3 kilometers.
3 kilometers. You understand? Total distance traveled is what here?
7 kilometers.
7 kilometers, right? You understand the difference? So it is having a direction. So I have to, the opposite direction in physics and all, what we do means sign conventions is very, very important. So opposite sign means we have to take it in a negative direction. Okay. So direction is when the direction is opposite, you have to use negative. Okay. But distance is just a measurement. So whenever I used to measure from this to this measurement also, it is 2 kilometers only. It's not minus 2 kilometers. Okay. Now you understand the difference? Yes. So till this, we'll wind up the class. So after all the things, we'll again continue in the next class. Okay. Thank you. Have a nice day. Thank you. Thank you. Just take it down this.
Okay.
Pawan, it's rushing to leave the class, right?
No.
Okay, you just 1 second stay back. Okay, so you are preparing for like day mains from now
Yes,
itself, right? Okay, you have to do more problems. You should not give up. In sometimes you feel difficulties, right?
yes,
Not all the chapters feel easy. Sometimes you get confusions, right? That and all you no need to do. You should not give up. Okay, you just have to try till you're having 2 years of time, right?
yes,
So you can go along with your subjects itself, and you have to start solving the J-means problem that we'll discuss in the next class. And if any doubts, you can sure ask us. Okay. If any faculties come to the class, you can ask us. You should not adjust with us, right? You should not feel. You should not hesitate to ask doubts. Okay. So any doubts you can ask, and we'll wind up the class today. Okay.
yes.
Yes. Thank you, Pawan. Yes.
For extra sums to practice, you will give or it's
Worksheets.
worksheets will give.
Yes, but now actually the class has started, right? So the previous worksheets and all will I'll tell the ma'am to provide you. Okay.
Yes,
So after when the class goes on, you can start solving that, and the previous year problems and all will solve in the class. Okay. So no confusions. I'll tell you in which year the problem has asked and how to solve these kind of problems, because going through a previous year problems helps you a lot to crack
yes,
JEE mains, right? Yes. So any doubts you can ask, okay? Shall we wind up the class today? Yes. Thank you. Thank you.